So in question 62, we've got a person who's making ice cream. And to make ice cream, what they have to do apparently is to turn a crank handle on an ice cream maker around in a circle. And to make it go around in a circle, they need to apply a force to it. And what we want to know is how much power is being expended by that person to make that crank handle go around in a circle. So power is equal to energy transferred. So this, in this case, would be the energy transferred to the handle by the person divided by the time over which that energy transfer takes place. So in this case, the energy being transferred is just the work done by the person on the handle divided by the time over which they do that work. So how much work are they doing? Well, let's consider how much work they're doing to turn it through one revolution. And the reason I want to consider one revolution is that we know that the handle gets turned once every 1.3 seconds. So if we know how much work is done during one revolution, to get the power out, we just need to take that work and divide it by 1.3. Now the work done on each revolution on a single revolution, the work done for a single revolution will be equal to the force times the distance the handle moves and we're told that the force that's being applied parallel to the motion of the handle is 22 newtons. And that's kind of handy because we know then that all the force is directed in the same direction as the motion. So all the force goes into doing work. So none of the force applied by this person is wasted. So the distance the handle moves in a single revolution is just going to be equal to the circumference of the circle through which the handle moves. And since we know what the radius is, we can just get that circumference because we know that the circumference of a circle is 2 times pi times the radius. So in this case, we have that the force, the work done for a single revolution is just going to be equal to the force being applied by the person multiplied by 2 pi r. And so where the force applied by the person is just 22 newtons, and the radius of the circular path that the handle moves on is 0.28 meters. And so now we can calculate that the power, hence the power expended by the person, going to be power equals to the work divided by the time for a single revolution where work, so the time is 1.3 seconds. So here we figured out the work done was just 2 pi r times the force, and now we're going to divide that by the time. So here, the power that they're expending will be 2 times pi times by the radius, which is 0.28 meters, times the force, which is 22 newtons, divided by the time, which is 1.3 seconds. And that's 29.8, and that's in joules per second, and that's equivalent to a watt. So the power being expended will be 29.8 watts. So in question 64 it says, you are working out on a rowing machine, which is just about one of the most unlikely scenarios I've ever seen in a physics problem. But be that as it may, each time I pull the rowing bar, which simulates the oars, towards me, it moves a distance of 1.2 metres in a time of 1.5 seconds. So it says the readout on display indicates that the average power that I'm producing is 82 watts. So I must be doing work on the handle when I'm pulling it towards me. So the power that I'm expending will be equal to the work that I'm doing divided by the time over which I'm doing that work. And I know how much work I'm doing, so work that I'm doing work done on, what are they? Rowing bar, work done on bar. So this will be the time to move the bar a distance of 1.2 metres. And we're told that power expended by me and that is equal to 82 watts. Now the work that I'm doing is just going to be equal to the force that I'm applying multiplied by the distance over which I'm applying it. So in that case we know that the power is going to be equal to force times the distance over which that is applied divided by the time it takes for me to apply the force, because I am pulling the rowing bar towards me. So I think we have to assume in this case that I'm applying my force in the same direction that the rowing bar is moving. Otherwise we'll need to know the angle between my force and the direction that the bars are moving, and I don't see that, so let's just make that assumption. And so what we want to do now is just solve for that force. So if we multiply both sides by time, we get that power times time is equal to force times the distance. And then lastly, we just want to solve for the force. So we just divide both sides by that distance. And so that force comes out to be 82 watts times time, which is, so in this case, time is equal to 1.5 seconds. So we're going to have 82 times 1.5 divided by 1.2, which gives us that I'm exerting a force of 102.5 newtons.